In the following situation, does the list of numbers involved make an arithmetic progression and why? Let's begin with the solution. It says the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So, according to the question, we are given taxi fare for the first kilometer is equal to rupees 15. Let us denote it by A1. Now, the taxi fare for the second kilometer, or we can say that for 2 kilometers, is equal to rupees 15 plus 8, and this is equal to rupees 23. And let us suppose A2 is equal to 23. Similarly, taxi fare for the third kilometer or for 3 kilometers is equal to rupees 23 plus 8, since for each additional kilometer rupees 8 is added, and this is equal to rupees 31. And let A3 is equal to 31. Similarly, we can calculate the taxi fare for the fourth kilometer or for 4 kilometers by adding 8 to 31, and so on. We can calculate the taxi fare for each additional kilometer. Thus, we obtain the list of numbers 15, 23, 31, 39 and so on. Now, let us check this list of numbers whether this is an AP or not. Now, this will be an AP if on subtracting any term from its succeeding term, the difference is same. That is, on subtracting 15 from 23, on subtracting 23 from 31, and on subtracting 31 from 39, if the difference is same, then it will be an AP. Let's check it out. First is A2 minus A1, that is 23 minus 15. This is equal to 8. Now A3 minus A2 is 31 minus 23. This is also equal to 8. A4 minus A3, 39 minus 31. This is also equal to 8, and so on. If we continue, we see that the difference between any two consecutive terms, that is, on subtracting any term from its succeeding term, the difference is the same. That is, AK plus 1 minus AK is always same, and hence the list of numbers form an AP with the first term 15 and the common difference 8. So, this completes the solution. In this question, we are given the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. We have to check whether the list of numbers involved in this make an arithmetic progression, and if yes, then why? Let us begin with the solution. Here, let the amount of air present in the cylinder be X, and let us denote it by A1. Now, the amount of air removed by the vacuum pump is equal to 1/4 of X, that is X upon 4. Therefore, the amount of air present in the cylinder after one time removal of air by the vacuum pump is given by X minus X upon 4, which is the amount of air removed by the vacuum pump, and this is equal to 3x upon 4 on simplification. Let us denote this by A2. Now, the amount of air removed by the vacuum pump is given by 1 upon 4 of A2, that is 1 upon 4 into 3x upon 4, which is equal to 3x upon 16. Therefore, the amount of air present in the cylinder after 2 times removal of air by the vacuum pump is given by 3x divided by 4 minus 3x divided by 16, and this on simplification comes equal to 9x upon 16, and let 9x upon 16 be equal to A3. Similarly, we can calculate the amount of air present in the cylinder after 3 times removal of air by the vacuum pump, and so on. We can calculate for the 4th time, 5th time, and so on. Thus, the list of numbers obtained is A1 is X, A2 is 3x upon 4, A3 is 9x upon 16, and A4 is 27x upon 64, and so on. Now, we have to check this whether it is an AP or not. First, let us find the difference of x and 3x upon 4, that is A2 minus A1. This is equal to 3x upon 4 minus x, which is equal to minus of x upon 4. And now let us find out a3 minus a2 is equal to 9x upon 16 minus 3x upon 4. Here the LCM is 16. In the numerator we have 9x minus 12x, and this is equal to minus 3x upon 16. Now here we see that the difference of a2 minus a1 is not equal to the difference of a3 minus a2. That is, on subtracting each term from its succeeding term, the difference is not same. Therefore, the list of numbers involved does not form an AP. This completes the solution. This question says, does the list of numbers involved make an arithmetic progression and why? Says, the cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. Let's first find the list of numbers involved. In this case, beginning with the solution. The cost of digging the well after 1 meter of digging is equal to rupees 150. Let A1 is equal to 150. Now the cost of digging the well after 2 meters of digging is equal to rupees 150 plus 50, since for the first meter it is rupees 150 and for each additional subsequent meter it is 50 rupees more. Therefore, here we have rupees 200. Let A2 is equal to 200. The cost of digging the well after 3 meters of digging is equal to rupees 200 plus 50, and this is equal to rupees 250. Let us denote it by A3. Thus, the list of numbers obtained is 150, 200, 250, 300 and so on. Now we have to check this whether this is an AP or not, right? This list of number will form an AP if we subtract each term from its succeeding term and the difference will be the same. That is A2 minus A1, 200 minus 150 is equal to 50. On subtracting A2 from A3, we have 250 minus 200 and this is equal to 50. Similarly, A4 minus A3, that is 300 minus 250 is equal to 50. Here we see that on subtracting each term from its succeeding term, the difference is common, which is 50. Therefore, we can say that the list of numbers form an AP. This completes the solution. In this question, under the following condition, we have to check whether the list of numbers involved make an arithmetic progression and why. Let's begin with the solution. The condition is the amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. Since we have to calculate the compound interest, therefore, we use the following formula, which is amount is equal to principal into 1 plus rate of interest divided by 100 raised to the power n, where n is the number of years. Here, the principal is rupees 10,000 and the rate of interest is 8. Therefore, amount for the first year is equal to rupees 10,000 into 1 plus 8 upon 100 raised to the power 1. Similarly, amount for the second year is equal to rupees 10,000 into 1 plus 8 upon 100 raised to the power 2. Amount for the third year is equal to rupees 10,000 into 1 plus 8 upon 100 raised to the power 3, and so on. We can calculate the amount for the 4th, 5th, 6th and so on years. Therefore, the list of numbers obtained is, first number is 10,000 into 1 plus 8 upon 100, second is 10,000 into 1 plus 8 upon 100 raised to the power 2, third is 10,000 into 1 plus 8 upon 100 raised to the power 3, and so on. Let us denote the first number by A1, second by A2 and third by A3. We have to check these numbers whether they form an AP or not, right? So what we will do is, we will subtract A1 from A2, A2 from A3 and check whether the difference is the same or not. If the difference comes out to be same, the following list of numbers forms an AP, otherwise they do not form an AP. First, let us find the difference of A2 and A1. This gives 10,000 into 1 plus 8 upon 100 whole square minus 10,000 1 plus 8 upon 100 raised to the power 1. This is equal to 10,000 into 1 plus 8 upon 100 into 8 upon 100. Now let us calculate A3 minus A2. Here we have 10,000 into 1 plus 8 upon 100 raised to the power 3 minus 10,000 into 1 plus 8 upon 100 whole square. This is equal to 10,000 into 1 plus 8 upon 100 whole square taking common, and here we are left with 1 plus 8 upon 100 minus 1. This is equal to 10,000 into 1 plus 8 upon 100 whole square into 8 upon 100. Now we see that the difference in both the cases is not the same. That is, A2 minus A1 is not equal to A3 minus A2. Hence, the list of numbers which are obtained under the following condition do not form an AP. This completes the solution. In this question, we have to find the first 4 terms of the AP when the first term A and the common difference D are given to us. Let's begin with the solution. Here we are given the first term, which is denoted by A is equal to 10, and also we are given the common difference D is equal to 10. The first term is already given to us. Now let us find the second term. Second term, that is denoted by A2, can be obtained by adding the common difference D to the first term, that is A plus 10 or 10 plus 10, since A is equal to 10. This gives the second term is equal to 20. Since in an AP, every succeeding term is obtained by adding the common difference D to the preceding term. Similarly, we can find the third term, which is obtained by adding the common difference to the second term, that is 20 plus 10, and this gives the third term as 30. Fourth term can be obtained by adding the common difference to the third term. This gives 30 plus 10 is equal to 40. Hence, the first 4 terms of the given AP are 10, 20, 30 and 40. So this completes the solution. This question says, write the first 4 terms of the AP when the first term A and the common difference D are given to us as follows. The first term is given to us as -2 and the common difference is 0. Let's begin with the solution. Here the first term is already given to us, which is -2, and also we are given the common difference D, which is equal to 0. Now we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. Therefore, the second term, let us denote it by A2, can be obtained by adding the common difference to the first term, that is -2 plus 0. This is equal to -2. Similarly, the third term can be obtained denoting it by A3 by adding the common difference to the second term. This is equal to -2, and the same way fourth term, that is A4, can be obtained by adding the common difference to the third term, which is equal to again -2. Hence all the terms of the given AP are same. Thus the first four terms of the given AP are -2, -2, -2 and -2. This completes the solution. In this question, we have to find the first four terms of the AP when the first term A is 4 and the common difference D is -3. Let's begin with the solution. Here we are already given the first term, 4. We have to find the next three terms, and also we are given the common difference. This is equal to -3. Now we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. Therefore, the second term, which is, let us denote it by A2, can be obtained by adding the common difference -3 to the first term, that is 4 plus of -3, and this is equal to 1. Similarly, the third term can be obtained by adding the common difference to the second term, that is 1 plus -3, this is equal to -2. The fourth term can be obtained by adding the common difference to the third term, that is -2 plus -3, this is equal to -5. Hence, the first four terms of the given AP are 4, 1, -2 and -5. This completes the solution.
In the given question, we need to find the first 4 terms of the AP when the first term A is -1 and the common difference D is 1/2. Let us proceed on with the solution of the given question. It is given first term is -1 and the common difference is 1/2. We know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. Therefore, the second term of the AP is denoting it by A2 can be obtained by adding the first term, that is -1, and the common difference 1/2. This is equal to, if we take the LCM, we get -2 plus 1/2. This equals -1/2. This is the second term. Now, let us find the third term of the given AP. Let us denote this by A3. This can be obtained by adding the previous term, that is -1/2, and the common difference, that is 1/2. This equals -1/2 plus 1/2 cancels each other, we get 0. Therefore, A3 is 0. Similarly, let us find the fourth term of the given AP. This can be obtained by adding A3, that is 0, and the common difference 1/2. We get 1/2. Therefore, we have got A4 as 1/2. Hence, the first 4 terms of the given AP are first term is -1, second term is -1/2, third term is 0, and the fourth term is 1/2. This completes the solution.
In this question, we have to find the first 4 terms of the AP when the first term A is -1.25 and the common difference D is -0.25. Let's begin with the solution. And here we are given the first term, denoting it by A, is equal to -1.25 and the common difference D, which is equal to -0.25. We know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term minus 1.50. Third term can be obtained by adding the common difference to the second term, that is minus 1.50 plus minus 0.25, and this is equal to minus 1.75. The fourth term can be obtained by adding the common difference to the third term, that is minus 1.75 plus minus 0.25. This is equal to minus 2.00. Hence, the first four terms of the given AP our first term is already given to us, minus 1.25. Second term is minus 1.50. Third term is minus 1.75. And the fourth term is minus 2.00. This completes the solution. This question says, for the following AP, write the first term and the common difference. Beginning with the solution, the given AP is 3, 1, minus 1, minus 3, and so on. From here, we can see that the first term is 3, let us denote it by A. This is 3, and now we have to find the common difference. It is obtained by subtracting any term from its succeeding term. First, let us denote the given terms by A, A1, A2, A3, and so on. Let us now find the difference of A1 and A. This is equal to 1 minus 3. This is further equal to minus 2. Now let us find A2 minus A1. This is equal to minus 1 minus 1. This is equal to minus 2. Similarly, you find out A3 minus A2. This is again equal to, on simplifying, minus 2. Hence, the first term of the given AP is equal to 3, and the common difference of the given AP is minus 2. So this completes the solution. This question says, for the following AP, write the first term and the common difference. Beginning with the solution, the given AP is minus 5, minus 1, 3, 7, and so on. Here we see that the first term is minus 5, denoting it by A, and we have to find the common difference. Common difference is obtained by subtracting any term from its succeeding term. Suppose if we take minus 5 to get the common difference, we will subtract minus 5 from its succeeding term, which is minus 1. So we have minus 1 minus of minus 5, and this is equal to minus 1 plus 5, which is equal to 4. Similarly, if we consider the term as minus 1, then on subtracting it from 3, we again get 4. Therefore, the first term of the given appears minus 5 and the common difference is 4. This completes the solution. This question says, for the following AP, write the first term and the common difference. The given AP is (1 upon 3), (5 upon 3), (9 upon 3), (13 upon 3), and so on. Now here we can see that the first term of the given AP is 1 upon 3, and the common difference is obtained by subtracting any term from its succeeding term. Suppose if we consider 1 upon 3, then the term which succeeds 1 upon 3 is 5 upon 3. Therefore, the common difference is equal to 5 upon 3 minus 1 upon 3, which is equal to 4 upon 3. Similarly, if we consider the term 5 upon 3, then the term which succeeds 5 upon 3 is 9 upon 3, and on subtracting 5 upon 3 from 9 upon 3 again gives 4 upon 3. Hence, our answer is the first term of the given AP is 1 upon 3 and the common difference is 4 upon 3. This completes the solution. For the following AP, write the first term and the common difference. The given AP is, beginning with the solution, (0.6), 1.7, 2.8, 3.9, and so on. Here, as you can see, the first term of the given AP is 0.6. Now we have to find the common difference. Common difference is obtained by subtracting any term from its succeeding term. Therefore, here if we consider the term 0.6, the term which succeeds 0.6 is 1.7, Therefore, common difference is equal to 1.7 minus 0.6, and this gives 1.1. Similarly, if we consider the term 1.7, then the term which succeeds 1.7 is 2.8, and on subtracting 1.7 from 2.8, again we get 1.1. Therefore, the common difference is 1.1. Hence, our answer is first term of the given AP is 0.6 and the common difference is 1.1. This completes the solution. This question says, which of the following is an AP? If they form an AP, find the common difference T and write 3 more terms. Let's begin with the solution. And the given list of numbers are 2, 4, 8, 16 and so on. Let us denote the given terms by A1, A2, A3, A4 and so on. The given list of numbers is an AP if the difference between any 2 consecutive terms remains the same. That is, if we subtract any term from its succeeding term, if the difference remains the same in all the cases, then it forms an AP. First, let us find A2 minus A1. This is equal to 4 minus 2, which is equal to 2. Now let us find out A3 minus A2. This is equal to 8 minus 4, which is equal to 4. Now, here we see that the difference of A2 minus A1 is not equal to the difference of A3 minus A2. Hence, the given list of numbers is not an AP, since the difference between the consecutive terms is not the same. In this question, we have to check if the given set of numbers form an AP, and if they form an AP, we have to find the common difference T and write 3 more terms. Let's begin with the solution. The given list of numbers is 2, 5 upon 2, 3, 7 upon 2 and so on. Let us denote the given list of numbers by A1, A2, A3, A4 and so on. The given list of numbers will form an AP if the difference between any 2 consecutive terms remains the same. First, let us find out A2 minus A1. This is equal to 5 upon 2 minus 2, which is equal to 2 LCM. In the numerator, we have 5 minus 4, which is equal to half. Now let us find out A3 minus A2. This is 3 minus 5 upon 2, and again here in this case the LCM is 2, and in the numerator we have 6 minus 5, and this is equal to 1 upon 2. Similarly, let us find out A4 minus A3. This is equal to 7 upon 2 minus 3, and here in the denominator we have 2, and in the numerator we have 7 minus 6. This is again equal to 1 upon 2. That is AK plus 1 minus AK is equal to half for all k's. So, the given list of numbers forms an AP, and the common difference between the terms here is equal to half. Now we know that in an AP, any term can be obtained by adding the common difference t to its preceding term. That is, we are already given 4 terms. To find the 5th term, we will add the common difference t to its 4th term. Now the 4th term is 7 upon 2. We will add the common difference half to 7 upon 2 to get the 5th term. And this will give 8 upon 2, which is further equal to 4. Now the 6th term is given by A5 plus d. The 5th term is 4 plus d is half. This is equal to half in the denominator, and numerator we have 8 plus 1. So this is equal to 9 upon 2. And now let us find the 7th term. This will be equal to 6th term plus the common difference. 6th term is 9 upon 2 and the common difference is half. This is equal to 10 upon 2, which is equal to. Hence, the next 3 terms are 4, 9 upon 2 and 5. So this completes the solution. The given question says, which of the following is an AP? If they form an AP, find the common difference t and write 3 more terms. Let's begin with the solution. And the given list of numbers is minus 1.2, minus 3.2, minus 5.2, minus 7.2, and so on. Let us denote the given list of numbers by A1, A2, A3, A4, and so on. Now this list of numbers forms an AP if the difference between any 2 consecutive terms remains the same. That is, AK plus 1 minus AK is same for all k. First let us find out A2 minus A1 is equal to minus 3.2 minus of minus 1.2. This is equal to minus 3.2 plus 1.2, which is equal to minus 2. Now let us find out A3 minus A2. This is equal to minus 5.2 minus of minus 3.2. This is equal to minus 5.2 plus 3.2, and this is again equal to minus 2. Similarly, let us find out A4 minus A3. So this is equal to minus 7.2 minus of minus 5.2, and this is equal to minus 7.2 plus 5.2, and this is equal to minus 2. That is, AK plus 1 minus AK is always the same, and which is equal to minus 2. And therefore, the given list of numbers form an AP with common difference minus 2. Next we have to find 3 more terms of this AP. And we know that in an AP, any succeeding term can be obtained by adding the common difference t to its preceding term. Here we are given 4 terms and we have to find the 5th, 6th and 7th term. So the 5th term is given by the sum of the 4th term and the common difference. 4th term is minus 7.2 and the common difference is minus 2. This is equal to minus 9.2. 6th term can be found by adding the 5th term to the common difference. So we have minus 9.2 plus minus 2, and this is equal to minus 11.2, and the 7th term is equal to the sum of the 6th term and the common difference, that is minus 11.2 plus minus 2, which is equal to minus 13.2. Hence, the next 3 terms of the given AP are minus 9.2, minus 11.2 and minus 13.2. So this completes the solution. This question says, which of the following is an AP? If they form an AP, find the common difference t and write 3 more terms. Let's begin with the solution. And the given set of numbers are minus 10, minus 6, minus 2, 2 and so on. Let us denote the given list of numbers by A1, A2, A3, A4 and so on. The given list of numbers forms an AP if the difference between any 2 consecutive terms remains the same. That is, AK plus 1 minus AK remains the same for any 2 consecutive terms. So first let us find out A2 minus A1. This is equal to minus 6 minus of minus 10. This is equal to minus 6 plus 10, which is equal to 4. Now let us find out A3 minus A2. So this is equal to minus 2 minus of minus 6, which is equal to minus 2 plus 6, and this is equal to 4. Also let us find out A4 minus A3. So this is equal to 2 minus of minus 2. So this is equal to 2 plus 2, which is equal to 4. Thus, we see that AK plus 1 minus AK is equal to 4, every time. Therefore, the given list of numbers form an AP with common difference 4. Now we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. Thus, 4 terms we are already given. We have to find the 5th, 6th and 7th term. The 5th term is given by the sum of the 4th term and the common difference. The 4th term is 2 and the common difference is 4. So the 5th term is 6. The 6th term is the sum of the 5th term and the common difference, and the 5th term is 6 and the common difference is 4. So we have 10. And the 7th term is the sum of the 6th term plus the common difference, that is 10 plus 4, which is equal to 14. Hence, the next 3 terms of the given AP are 6, 10 and 14. So this completes the solution. This question says, which of the following is an AP? If they form an AP, find the common difference D and write 3 more terms. Beginning with the solution. The given list of numbers is 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, and so on. Let us denote the given list of numbers by A1, A2, A3, A4 and so on. Now, the given list of numbers form an AP if the difference between any 2 consecutive terms remains the same, that is, AK plus 1 minus AK always remains the same. First, let us find out A2 minus A1. So this is equal to 3 plus root 2 minus 3. This is equal to root 2. Now let us find out A3 minus A2. This is 3 plus 2 root 2 minus 3 plus root 2. So this is equal to 2 root 2 minus root 2, and this is equal to root 2. Similarly, let us find out A4 minus A3. This is equal to 3 plus 3 root 2 minus 3 plus 2 root 2, which is equal to 3 root 2 minus 2 root 2. This implies again root 2, that is AK plus 1 minus AK is equal to root 2, that is the difference between any two consecutive terms always remains the same, which is equal to root 2. Thus we can say that the given list of numbers form an AP. And the common difference is the difference between any two consecutive terms, denoting it by D, and this is equal to root 2. Now as per the question, if the given list of numbers form an AP, then we have to find 3 more terms. And we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. And we are already given 4 terms. We have to find the 5th term. So 5th term is given by adding the common difference D to the 4th term. The 4th term is 3 plus 3 root 2, and the common difference D is root 2. So this is equal to 3 plus 4 root 2. Now let us find the 6th term, which is equal to the sum of the 5th term and the common difference. This is equal to 3 plus 4 root 2 plus the common difference is root 2. So this is equal to 3 plus 5 root 2. The 7th term is the sum of the 6th term and the common difference. So we have 3 plus 5 root 2 plus root 2, and this is equal to 3 plus 6 root 2. Hence, for the given set of numbers which forms an AP, the next 3 terms are three plus 4 root 2, 3 plus 5 root 2, and 3 plus 6 root 2. So this completes the solution. This question says, does the given list of numbers form an AP? If they form an AP, find the common difference D and 3 more terms. Let's begin with the solution. And the given list of numbers is 0.2, 0.22, 0.222, 0.222 and 2, and so on. Let us denote each term of the given list of numbers by A1, A2, A3, A4 and so on. Now, the given list of numbers form an AP if the difference between any two consecutive terms remains the same. That is, AK plus 1 minus AK always remains the same. Let us find out A2 minus A1. This is equal to 0.22 minus 0.2, and this is equal to 0.02. Now let us find out A3 minus A2. This is equal to 0.222 minus 0.22. So this is equal to 0.002. Now here we see that A2 minus A1 is not equal to A3 minus A2? That is, on subtracting any term from its succeeding term, the difference is not always the same. Hence, the given list of numbers do not form an AP. This completes the solution. This question says, does the given list of number form an AP? And if they form an AP, find the common difference D and write 3 more terms. The given set of numbers are 0, minus 4, minus 8, minus 12 and so on. Let us denote the terms of the given list of numbers by A1, A2, A3, A4 and so on. Now this list of numbers form an AP if the difference between any two consecutive terms always remains the same. That is, A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 and so on. In short, we can write AK plus 1 minus AK always remains the same. Let us now find out the difference. First we find A2 minus A1, so this is equal to minus 4 minus of 0 and this is equal to minus 4. Now let us find out A3 minus A2. This is equal to minus 8 minus of minus 4. This is equal to minus 8 plus 4, which is equal to minus 4. Now let us find out A4 minus A3. This is equal to minus 12 minus of minus 8 and this is equal to minus 12 plus 8, which is equal to minus 4. Thus we see that the difference between any two terms is minus 4 and hence we can say that AK plus 1 minus AK is equal to minus 4. That is, the difference of any term from its succeeding term is always the same, which is equal to minus 4, and thus the given list of numbers form an AP. Now we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. In this case, the common difference is minus 4. Let us denote it by small d. Therefore, let us now find out the fifth term, since we are already given the 4 terms and we have to find the next 3 terms. So the fifth term is given by the sum of the fourth term and the common difference. The fourth term is minus 12 and the common difference is minus 4. So this is equal to minus 16. Let us now find out the sixth term. It is the sum of the fifth term and the common difference, that is minus 16 plus minus 4, which is equal to minus 20. And the seventh term is the sum of the sixth term and the common difference, that is minus 20 plus minus 4. So this is equal to minus 24. Hence, the given list of number forms an AP, and the next three terms of the given AP are minus 16, minus 20 and minus 24. So this completes the solution. In this question we have to find whether the given list of numbers form an AP, and if they form an AP we have to find the common difference t and write three more terms of the given list of numbers. Let's begin with the solution. And the given list of numbers are minus half, minus half, minus half, minus half, and so on. All the numbers of this list are same. Let us denote each term by A1, A2, A3, A4 and so on. We have to find whether the given list of numbers is an AP or not, right? And we know that the given list of numbers will form an AP if the difference between any two consecutive terms always remains the same, that is A2 minus A1, A3 minus A2 and A4 minus A3 always remains the same. We can also write AK plus 1 minus AK always remains the same. So let us find out first A2 minus A1. This is equal to minus half, minus of minus half, which is equal to 0. Now let us find out A3 minus A2. So this is equal to minus half, minus of minus half. This is again equal to 0. Now let us find out A4 minus A3. This is minus half, minus of minus half, which is again equal to 0. That is AK plus 1 minus AK is always equal to 0 for all the consecutive terms. Thus, the given list of numbers form an AP. And the common difference is equal to 0. Let us denote the common difference by D. Now in the question we are given, if the list of numbers is an AP, we have to find the next three terms, and we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. This implies that the fifth term is equal to the sum of the fourth term and the common difference. Since we are already given four terms, we have to find the fifth, sixth and seventh term. Now the fourth term is minus half and the common difference is 0, so the fifth term is also minus half. Similarly, the sixth term, which is the sum of the fifth term and the common difference, is again equal to minus half plus 0, which is again equal to minus half. And the seventh term is the sum of the sixth term and the common difference. This is again equal to minus half plus 0, which is equal to minus half. Hence, the given list of numbers form an AP and the next three terms are minus half, and minus half. So this completes the solution. This question says, does the given list of numbers form an AP, and if they form an AP, we have to find the common difference and write three more terms. Let's begin with the solution. The given list of numbers is 1, 3, 9, 27 and so on. Let us denote the terms of the given list of numbers by A1, A2, A3, A4 and so on. This list of numbers will form an AP if the difference between any two consecutive terms always remains the same. That is, A2 minus A1, A3 minus A2, A4 minus A3 and so on always remains the same. That is, AK plus 1 minus AK always remains the same. So to check whether the given list of numbers is an AP or not, let us find the difference of consecutive terms. First, let us find out A2 minus A1. This is equal to 3 minus 1, which is equal to 2. Now let us find out A3 minus A2. This is equal to 9 minus 3 and this is equal to 6. Now let us find out A4 minus A3. This is equal to 27 minus 9 and this is equal to 18. Now here we see that A2 minus A1 is not equal to A3 minus A2, which is not equal to A4 minus A3. Thus, the difference of any two consecutive terms is not the same. Hence, the given list of numbers do not form an AP. This completes the solution. This question says, which of the following is an AP? If they form an AP, find the common difference D and write three more terms. Let's begin with the solution. And the given list of numbers is A, 2A, 3A, 4A and so on. Let us denote each term of the given list of numbers by A1, A2, A3, A4 and so on. Now the given list of numbers form an AP if the difference of any two consecutive terms always remains the same. That is A2 minus A1, A3 minus A2, A4 minus A3 and so on always remains the same. That is AK plus 1 minus AK always remains the same. Let's check this out. First let us find the difference of A2 and A1. This is equal to 2A minus A. This is equal to A. Now let us find out A3 minus A2. This is equal to 3A minus 2A, which is equal to A. Also let us find out A4 minus A3. This is again equal to A. And this implies that AK plus 1 minus AK always remains the same, and this is equal to A. That is, the difference between any two consecutive terms is always the same, which is equal to A. Thus, the given list of numbers form an AP, and the common differences, let us denote it by small d, is equal to A. Now we know that in an AP, every succeeding term can be obtained by adding the common difference d to the preceding term. As per the question, we have to find the next 3 terms, and 4 terms we are already given. Therefore, to find the 5th term, we will add the common difference d to the 4th term, and this gives 4A plus A, which is equal to 5A. Now let us find the 6th term, which is the sum of the 5th term and the common difference. This is equal to 5A plus A, which is equal to 6A. And the last term which we have to find is the 7th term. This is equal to the 6th term plus the common difference. That is 6A plus A, which is equal to 7A. Hence our answer is the given list of numbers form an AP, and the next 3 terms are 5A, 6A and 7A. This completes the solution. This question says, is the given list of numbers an AP? If they form an AP, find the common difference d and write 3 more terms. Beginning with the solution, the given list of numbers is A square, A cube, A raised to the power 4 and so on. Let us denote the terms of the given list of numbers by A1, A2, A3, A4 and so on. The given list of numbers will form an AP if the difference between any 2 consecutive terms of the given list of numbers always remains the same. That is, AK plus 1 minus AK always remains the same. First, let us find out a2 minus a1. This is equal to a square minus a. Taking a common, we have a into a minus 1. Now let us find out a3 minus a2. So this is equal to a cube minus a square. Now taking a square common, we have a minus 1. Now here we see that a2 minus a1 is not equal to a3 minus a2. This implies that the difference between any two consecutive terms is not the same. Hence, the given list of numbers do not form an AP. This completes the solution. This question says, is the given list of number an AP, and if they form an AP, find the common difference T and write 3 more terms. Beginning with the solution, the given set of numbers are root 2, root over 8, root 18, root 32, and so on. The given list of numbers can also be written as root 2, root over 2 square into 2, root over 3 square into 2, root over 4 square into 2, and so on, or square root of 2, 2 square root of 2, 3 square root of 2, 4 square root of 2, and so on. Let us denote the terms of this list of numbers by A1, A2, A3, A4, and so on. Since these two lists of numbers are the same, we will check whether this list of numbers form an AP or not. Now we know that the given list of numbers form an AP if the difference between any two consecutive terms remains the same. That is, a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, and so on. Or in other words, we can say that if ak plus 1 minus ak always remains the same. Let's check it out. First, let us find a2 minus a1. Now a2 is 2 root 2 and a1 is root 2. Taking root 2 common, we have 2 minus 1, which implies root 2. Now let us find a3 minus a2. This is equal to 3 root 2 minus 2 root 2. Taking root 2 common, we have 3 minus 2, which is equal to 1 root 2 or root 2. Let us find out now a4 minus a3. This is equal to 4 root 2 minus 3 root 2. Taking root 2 common, we have 4 minus 3, and this is again equal to 1 root 2 or root 2. That is, we can say ak plus 1 minus ak is equal to root 2, or if we subtract any term from its succeeding term, the difference remains the same. Thus, the given list of numbers form an AP with common difference T equal to square root of 2. Now, according to the given question, if the given list of numbers form an AP, then we have to find the next three terms. And we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. And here we are already given 4 terms. We have to find the 5th, 6th and 7th term. First, let us find out the 5th term, which is the sum of the 4th term and the common difference. 4th term is 4 root 2 and the common difference is root 2. This is equal to 5 root 2. This can also be written as a square root of 5 square into 2, which is equal to square root of 50. Now let us find out the 6th term, which is equal to the sum of the 5th term and the common difference. And the 5th term is 5 root 2. So 5 root 2 plus root 2 is equal to 6 root 2. And this can be written as square root of 6 square into 2, which is equal to square root of 72. Now let us find out the 7th term. It is given by the sum of 6th term and the common difference. So this is equal to, the 6th term is 6 root 2. So we have 6 root 2 plus root 2. And this is equal to 7 root 2. This can be written as 7 square into 2. That is 49 into 2, which is equal to square root of 98. Hence we can say the given list of numbers form an AP and the next three terms, that is the 5th, 6th and the 7th terms are root over 50, root over 72 and root over 98. So this completes the solution. This question says, is the given list of number an AP? If they form an AP, find the common difference D and write 3 more terms. Let's begin with the solution. And the given list of numbers is square root of 3, square root of 6, square root of 9, square root of 12 and so on. Let us denote the terms of this list of numbers by A1, A2, A3, A4 and so on. The given list of numbers will form an AP if the difference between any two consecutive terms always remains the same. That is, A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 and so on. Thus we can write, if AK plus 1 minus AK always remains the same. Let us first find out A2 minus A1. So this is equal to square root of 6 minus the square root of 3. Square root of 6 can be written as square root of 2 into square root of 3 minus the square root of 3. This is equal to square root of 3, and inside the bracket we have square root of 2 minus 1. Now let us find out A3 minus A2. This can be written as square root of 9 minus square root of 6. This is equal to square root of 9 is square root of 3 into square root of 3, and square root of 6 can be written as square root of 3 into square root of 2. Taking square root of 3 common, we have square root of 3 minus square root of 2. From here we see that a2 minus a1 is not equal to a3 minus a2, since root over 3 into root over 2 minus 1 is not equal to root over 3 into root over 3 minus root over 2. Thus we have a2 minus a1 is not equal to a3 minus a2. Hence, the given list of numbers do not form an AP. This completes the solution. This question says to check if the given list of numbers is an AP, and if they form an AP, find the common difference t and 3 more terms. Beginning with the solution, the given list of numbers is 1 square, 3 square, 5 square, 7 square, and so on. Let us denote each term of the given list of numbers by A1, A2, A3, A4, and so on. Now we know that the given list of numbers will form an AP if the difference between any two consecutive terms remains the same, that is a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, and so on. That is if, in other words, ak plus 1 minus ak always remains the same. First, let us find out a2 minus a1. a2 is 3 square minus 1 square. 9 minus 1 is 8. Now let us find out a3 minus a2. a3 is 5 square minus 3 square. This is equal to 25 minus 9, and this is equal to 16. Now from here we can see that a2 minus a1 is not equal to a3 minus a2. That is, the difference of any term from its succeeding term is not the same. Hence, the given list of numbers do not form an AP. This completes the solution. This question says, which of the following is an AP? If they form an AP, find the common difference t and write the 3 terms. Here, the given list of numbers is 1 square, 5 square, 7 square, 73, and so on. Let us denote the terms of the given list of numbers by A1, A2, A3, A4, and so on. Now, the given list of numbers form an AP if the difference between any two consecutive terms always remains the same. That is, the difference between a2 minus a1 A3 minus A2, A4 minus A3, and so on always remains the same. In other words, we can also write the given list of numbers form an AP if AK plus 1 minus AK always remains the same. First, let us find out A2 minus A1. This is equal to 5 square minus 1 square, which is 25 minus 1, and this is equal to 24. Let us now find the value of A3 minus A2. This is equal to 7 square minus 5 square. 7 square is 49 and 5 square is 25. Now this is equal to again 24. Now let us find the value of A4 minus A3. This is equal to 73 minus 7 square, that is 73 minus 49, and this is again equal to 24. Thus we see that the difference between any term and its succeeding term is always the same, and this is equal to 24. Hence we can say the given list of numbers form an AP with common difference that is denoted by D, and that is equal to 24. Now we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. That is, to find the fifth term, we will add the common difference to the fourth term, and the fourth term is 73. On adding 24 to 73, we get 97. Let's now find out the sixth term. This we will get on adding the fifth term to the common difference. And the fifth term is 97 and the common difference is 24, and this on simplifying comes equal to 121. Now let us find the seventh term. This is equal to A6 plus D, that is the sixth term plus the common difference. This is equal to 121 plus 24, and this is equal to 145. Hence, our answer is the given list of numbers form an AP and the next three terms are 97, 121 and 145. So this completes the solution.